Good morning, everyone. For anybody who doesn't know me, my name is Carly Perry. I'm Managing Director of Spring Innovation. For anyone who doesn't know Spring Innovation, we are the Water Sector Innovation Centre of Excellence for the UK and Ireland. We're supported by all 18 water companies across the UK and Ireland, and we've been designed to remove duplication from the innovation space. There is fantastic regional pieces of innovation happening across the UK and Ireland, but a very conservative average is that an innovation project is duplicated 4 times. So we are here to better connect the existing excellence that is out there to make sure that we are being as efficient as we can with solving the problems that the sector has. So our goal is to share insights from existing innovation with all water companies, with broader stakeholders, with the global community as well. We are the custodian of a document called the Water Innovation Strategy in the UK and Ireland, lays out the ambition up until 2050, and there's short, medium and long-term ambitions in there that are really useful guides for anybody who's an innovator out there. The Spring team are going to drop some links into the chat, so whenever I reference something, there will be links there for you to help you as well. I'm really happy to say that the showcase you're going to see today actually covers quite a few of the themes from the Water Innovation Strategy, and the team will go into more detail about that in just a minute. From a Spring perspective, though, we have 2 core service offerings. One is the Spring Accelerator, where we put calls for innovation out. We've already done 2 calls for innovation, one around net zero, one around delivering resilient infrastructure. We have 10 innovations in our portfolio at the moment, with differing activity from mentoring to mobilising trials. We also are going to put a call for innovation out in January around enhancing and protecting natural systems. So for any innovators out there who are offering solutions in that space, please make sure that you keep connected with us over the next few months as we give more information about that. But the service offering that you're going to be a part of today is our knowledge transfer service offering. And this is all about accelerating innovation in the sector by sharing insights of things that already exist. So we have 2 core parts to this. We've got a knowledge library, which sits on the Spring platform, and there will be a link in the chat to that. That library currently has 46 case studies in it, with 80 odd in the pipeline. You can go and search by the Water Innovation Strategy themes for knowledge that can help you. So, for example, you could search by resilient infrastructure or net zero, and you can find case studies of innovation with lessons learned from other people to help you accelerate your journey. These sessions we call showcases. So these are deep dive 2-hour sessions where a whole project team, water company and suppliers come together to share their insights from a particular project that they've worked on. So the whole goal is to give you enough information that you can then go away and think about how you can embed this in your business. So if you are interested at the end of this, get in touch with the project partners to talk about exactly how you can take the knowledge. So this is showcase number 12. We have delivered showcases across most Water Innovation Strategy themes. So those showcases all get recorded, uploaded to our platform, and then you can rewatch those. So if you want to go back to any of those 12 that have already happened, you can do that on our platform, and access is open to anyone. So please go and have a poke around and see what would suit your needs in there. But we've now had nearly 2,000 people register for these showcases, so they are really hitting a spot for people to come and learn from other people's experience. We've had over 200 people register for this showcase today, which is fantastic. It means that this is really hitting a knowledge area that people are interested in. Very happy to say we have a lot of global interest in this one as well. So welcome to our global attendees from Australia, New Zealand, Denmark, Japan and Canada. I think that is the most broad reach that we've had so far, so that's fantastic to see. As I mentioned, everything will get recorded, so you'll get sent a link to this afterwards so you can share that with colleagues. Knowledge sharing is really gaining traction, especially in the UK and Ireland at the moment, where we have a huge amount of knowledge to share with each other. We're really happy to say that we're working with Ofwat to make sure that the knowledge from the Ofwat Innovation funded projects is shared across the sector. This project that you're going to see today is one of those. If you are a water company or a supplier and you want to share knowledge around a project, please get in touch with us, because we are here to help you do that. And the links that have been put in the chat will help you to get to more information on that. Okay, so that is enough about Spring and about knowledge sharing. On to today's session. So I'm going to walk you through the agenda of what we're going to cover. So if we can flick through to that slide, please. Thank you very much. So welcome and introductions first up, and then we've got the problem and project background, the project process, the lessons learned, and Q&A. And the lessons learned piece of this is so critically important, because we ask the presenters to be really honest about what has gone well, what has been challenging, what did you struggle with along the way, and what can other people learn from those challenges that you had. So that's a really fundamental piece of this puzzle. So today, very happy to say that we are going to hear from presenters around an AI and sewer analysis project. And we are going to hear from Kieran Brocklebank, who is Head of Innovation at United Utilities, who will lead on this alongside other water company partners that will be introduced shortly. Peter Henley, Principal Consultant from Wastewater Infrastructure at WRC, and Justine Leadbetter, Senior Consultant, Leakage and Water Resources at WRC. So all that's left for me to do is say a huge thank you to the project partners, to United Utilities, to WRC, to all the other water companies who are involved in this project. We really appreciate you being open with this knowledge and sharing so that others can accelerate their learning experience. So with that in mind, I'm going to hand over to Kieran Brocklebank. Thank you, Kieran.
Thank you very much, Carly, and thank you to Spring for giving us the chance to share to the sector, to the wide audiences that we really need to connect with, because we've got an exciting story to tell you today. We've got a story about how several partners, water companies who'd never really collaborated on a project like this before, working with a well-established delivery partner, WRC, but we've never done one of these projects together in this way to publish something for the sector under the rules of the Ofwat Fund. And in this particular case, we kickstarted this project way back in the early embryonic stage of the Ofwat Innovation Fund, all the way back in those years to IWC1, the Innovation in Water Challenge Round 1. And we're going to tell you a story today between myself, Peter and Justine. We're going to tell you a story today all about how we moved that project along, how we as partners work together, the technical aspects of our solution, some of the dilemmas, the blockers that we faced along the way. And I hope that you receive all of that information with the spirit that it's being delivered, in the spirit of knowledge share. We're going to get vulnerable. We're going to expose where we didn't get things right first time. We're going to show you how we bounced back, and we're going to show you how we are today publishing a solution that absolutely hits something that's going to be great for the sector. Okay, Chloe, would you please move us on in one of the slides, please? Thank you. So I mentioned that this project was started all the way back in the early stages of the Ofwat Innovation Fund. And this is a story then about how these partners on the screen have worked together. We've not all had the same roles all the way through the project. And if those of you who are familiar with the Ofwat Innovation Fund, you know there are at least two roles that need to be defined. One is the lead partner, of which United Utilities, the company that I'm here representing as an individual water company, that's who I work with. We were the lead partner. And we, together with our partner companies, logos that you can see on the screen, the other water companies, we agreed to work with WRC as our delivery partner. They're the people who have to kind of knit all this together, bring the different technical aspects of all the different water companies, all those end users with all of their individual biases and all their individual ways of working. It's the delivery partner's job to try and coordinate all of that and get the outcome that we're looking for. An outcome that, as we all know in project delivery, an outcome that meets time dilemmas, cost and quality, and tries to balance all of those. And so with that project team in mind, just a quick reminder then, we'd never worked formally under these arrangements before. We had a risk log, like loads of great projects do, where we tried to identify up front what are all the kind of dilemmas that we might face. Let's put them on a risk log. Let's do some, clever thinking at the beginning of the project before we're in the white hot heat of delivery. Why don't we think about all of those things? And you will not be surprised to learn, audience, that original thinking was revisited several times and of course added to as we went along. We discovered dilemmas, problems, blockers, opportunities. We discovered things along the way that we could not have thought of in advance and did not. There's a partner in this project whose logo is not mentioned there, but I would like to, and that of course is Ofwat themselves, the Ofwat Innovation Fund team, the Challenge Works team. Because all the way along this project, we've been reporting to them on progress, on blockers that we found, risks that were materializing, opportunities that were there for the taking. And I must say that the response from the Challenge Works and Ofwat team has been great all the way along this project. They've taken our reporting in good faith. They've been pragmatic, realistic, and they've allowed us to increase the scope where we saw opportunity, and they've allowed us to take a little bit longer time where we felt we needed to. So thank you on behalf of the project team. Thank you to everyone who's contributed. Also a nod to some people who have helped. We also, as you'll discover with this project, we also engaged with a few third-party AI wastewater CCTV specialists along the way as well. We probably couldn't call them formal partners in the definition of the Ofwat Fund arrangements, but we have sought opinion, sought guidance, feedback from lots and lots of places. Okay, so here's the collaborators, some of which are named on here and some who are not named, but collectively we've all delivered a great project. So let's move on to the next slide, please, where, quick reminder, Carly was talking about Spring, who are the custodians of the water innovation strategy. Oh, I'm sorry, have we missed the strategy slide? I beg your pardon. I think there was one back. There we go. Thank you. And it's normally me who clicks too fast on these things. It's from my old video game days. Here we are. So the custodians of the water innovation strategy, which was, of course, developed several years ago now by lots of people inside the water sector and outside the water sector, regulatory bodies, third-party suppliers, academia, consultants, law firms, and water companies, of course, classic, who you might imagine got involved. Today's story then, if we're looking at the 5 aspects of the strategy, the 5 aspects that we need coordinated partnership innovation effort, today's story then probably hits the top one, the third one, and the 5th one. So 1, 3, and 5. And we've gone for the odd numbers, and it's a bit of an odd project. And all of these aspects of the water strategy, of course, are absolutely aligned to anything that you might see in the UCWIA Big Questions, Spring as an entity, and of course, individual water companies. So our story today is about a project that fully meets several of these aspects of the strategy. Okay, now let's move on then to getting into the nuts and bolts of what this real opportunity was to work together. Okay, quick reminder on the left-hand side then. The water sector strategy encourages us to partner on 1, 3, and 5 in this example. The Ofwat Innovation Challenge very early on, as we know, Ofwat have allowed for extra investment, which comes with some partnership rules. rules around you have to collaborate with other water companies, you have to make all the results public, you can't make them bespoke and unique to individual water companies, has to be sector benefit. And in this particular case, the rules of the fund that we applied for had to deliver a return within our AMP7 period, so before 2025. And so we will be disseminating our results today in 2023, hoping but knowing that benefits will come from today. In fact, we've already landed a whole load of benefits around partnership working. And in fact, you know, we've got good benefits realization already, but the real benefits in this story come from today. And of course, one of the rules was around data solutions must be open source. So not just that they're public and visible, but they must be accessible. So they can't be in any kind of proprietary format or locked into the formats of a particular supplier or provider. Okay, so that's the left-hand side. That's one aspect, and the other converging aspect is the problem. Across the world, our wastewater sewer network is classed as critical infrastructure. It's part of our everyday operations. It's something that our customers, businesses rely on every day. And the classic method of checking the condition of that critical infrastructure is using CCTV cameras that go inside the pipes. They move along on little robot trucks, or they are pushed along by humans, or it's some other mechanism of moving a video or photographing camera all the way along that pipe. And that's the method of doing all of that. But every single one of those aspects generates tons and tons of footage. All of that footage then needs to be watched. And today's classic solutions, most companies around the world, that is mostly human centric, men and women, all day, every day, watching footage after footage after footage. And sometimes that footage is just watched there and then locally. That data, that CCTV footage, is not stored and reused. It's usually used once. And so that felt a bit of a gap to us, really. I wonder if there was some way of kind of reusing some of that information. The reason that we're watching those videos, of course, is to check on the condition and turn that into some operational intervention, whether that's a local repair or whether in some severe cases, or that's about a replacement. And in terms of who's looking at that footage and who is doing that repair, water companies around the world have a mixture of how they do that. Some of them outsource to supply chain partners, some of them do it in-house, but of course water companies typically own that infrastructure, so they should take care of what that data is used for and how it's stored. Okay, Chloe, let's move us on. So a bit more context then about what you're going to hear today. We've just explained all around sewer inspection, and that's going to be what our story and knowledge share is around today. Let's go into a bit more detail. So here we are again. Third column probably is where I want to start on this slide. The current method of watching that footage is slow. It's laborious, it's certainly labor intensive and repetitive. Men and women constantly fast forwarding, rewinding, advancing, pausing, looking at that footage and trying to take their glasses off and push their tongue out and scrutinize this footage. How is it that we can interpret what we can see inside the pipe and turn that into an operational intervention? And what we found, of course, was that labor intensive, slow, repetitive process, it feels like it should be on the road to digitization. And so there's been innovation already in software to analyze that footage and to automatically prompt some sort of defect, a defect recognition, and maybe then prompt what is the repair type that we might need. The key to all of that, whether you're doing that in-house in a water company, or whether you've outsourced that, or whether you're doing that in partnership with others, the key to all of that is these models, these automated systems, artificial intelligence, machine learning models, we all know what they rely on is accurate data, and lots of it. And of course, individual water companies working in silo, they're probably not going to have the volume of data, and certainly not the effort required to cleanse their data suitable for feeding into a model. They're probably not going to be able to do that all on their own. And that's why this project came about and was born in terms of let's go for innovation funding, let's produce a sector-wide approach. Next slide, please. So now let me head towards the end of my section, which is describing the problem and the opportunity of how we've set ourselves up. Next slide, please, Chloe. Thank you, because what we're going to tell you about today is how all of those partners came together. We've delivered a collaborative project. It involved water companies, our delivery partner WRC, and those AI vendors, as I mentioned earlier, who we've consulted with, to create a volume of data, a single version of the truth that we can assess ourselves against, and any company, whether it's a water company, an existing AI vendor, or a brand new service provider who might take that information and spot some insight that we just have never seen before. This is an example of Spring, as they described earlier, about removing duplication. Instead of us all doing that cleansing to get on our own in silo, why don't we do it together? And what we've agreed to do is produce this single data set, make it accessible for this sewer footage, codification, meaning classify it, describe it, and publish it in a way that is meeting all the standards that we need. And of course, all this was happening before the other sector-wide collaboration, Stream, which is all about data. This was all kicked off and all being formed and all being run before Stream was ready enough for us. Now, just before I move on to my final slide and then I hand over to WRC, I think it's worth just pausing here and just discussing partnership behaviour just a touch. Because as I said, we'd never worked together before in this way. Whilst we may have known each other, and certainly in all of the water companies' case, WRC were familiar to us, it's worth pointing one thing out, which is WRC in this project have been absolute superstars. And I would like, on behalf of the other water companies, to call that out. This project did not go well from day one, with no fault of WRC. It's just a symptom of the project that we were running, a little bit of the design of the Ofwat fund. But WRC stuck with us. They've coordinated us. They've got us through all the technical hurdles, but they've also got us through collaboration hurdles, intellectual property dilemmas, partnership working. How on earth do you publish large data sets? How do we clean data when some partners promise to do some work and then we're not able to do so? Absolute fantastic resilience, problem solving, and just that general can-do attitude from WRC. And on behalf of our water company partners, I would like to call that out just on this slide. So thank you very much, WRC, and I hope to see lots and lots of clap emojis coming through for the recording, please. I'd love our audience to do that. I will certainly do that. All right, and then we move on to our final solution. And final slide, sorry, Chloe. Oh, thank you for all of that recognition. It's well deserved, certainly. Here's my final slide, and then I'll hand over to Peter from WRC. So quick reminder, our solution then had many work streams. It was about partnership working. It was about creating that data set. And really the kind of grand vision that we came together to do was to try and deliver a solution that meets those 5 bullet points on the right-hand side to enable a data set that would allow artificial intelligence, this digitization, allow us to start grabbing some of that potential, to provide that single data set, the one version of the truth that we're all happy with, not individual companies happy on their own, but a collective on behalf of the sector. A first time sharing of this cross-sector way of working, all of the coding and classification. And of course, ultimately, this should lead to water companies being able to deliver a much better service. So before I hand to Peter, a quick reminder, our story today is about sharing that knowledge. It's about setting how we set ourselves up as a project, which I've just delivered. Peter's going to drag us through the technical aspects and share some of that because it's fascinating stuff. And Justine then is going to wrap us up talking about the collaboration aspects, what we learned, what we'd love to have gone back in a time machine and done differently. And then we can open up for a break and then some questions and answers. For now, then, thank you very much for your participation and listening. I'll hand over to Peter. Thank you.
Thank you, Kieran, and good morning, everybody, and thanks for joining this session. I'm going to try and talk to you about the technical aspects of where the project arrived and how we've sort of progressed our way through that. My background is in sewer condition assessment, and we've worked with WRC. We've got the MSCC, which is the recognised coding assessment strategy for the not only the UK water industry, but it's been adopted quite widely across the globe. So we realised that, and we've been looking at the benefits of potential automatic defect recognition since probably about 2005. But I think now with development in digitisation, data, computer power, etc., we're much more in a better place. But we recognise there are AI solutions out there, and having had various discussions with those vendors and with the water companies who are developing their own solutions, one of the big obstacles to improving the solution up to a really good level that it could be practically used was the lack of data. So this project really tries to address that and to populate that. As Kieran said, if you just rely on one water company's data set, that's got to be insufficient. So we needed to pull that. So hence we got partner organisations, 7 in total, where we could draw in video footage from each of those companies and then utilise that and identify the key defects that we were trying to assess. So that's pretty easy, really. Just get all of the data from all the water companies and then codify and classify that. Well, that was the initial starting point. We then realised that just staring at hours and hours of footage was going to be not only time consuming, we'd probably be still working for the next decade. So we needed to accelerate that process. So we asked all of the water companies not only for their CCTV footage, and we got 1 terabyte from each of the water companies involved. We also wanted their metadata because we realised that rather than sit hours and hours of pipes with no defects in there and just wasting our time, we needed to fast forward to those key points in that video footage and then be able to classify and codify them and accept them and utilise them in the data library. So we not only collected the CCTV footage, but also the metadata as well, which is for those CCTV specialists or geeks out there, XML data was what we were after. So yeah, so we, rather than, as I say, look at staring down the pipe for hours on end, we utilised the CCTV footage and we created images spliced from that footage using the metadata. So where the metadata said there was a fracture, we were able to fast forward to that point, capture the image, and then we could specify that, upload it into a defect folder, and then we could then process that through. As we all know, in many pieces of footage, there are multiple defects in one location. So in those instances, we separated each of those defects out. So we had a folder for fractures, cracks, but also tree roots and things like that. So we were able to create a huge data repository, which we then could work our way through, codify and classify. So this produced quite a daunting amount of numbers. We originally had 180,000 individual defects, and we then created from that nearly 750,000 images to review, from which we finally settled down onto 27,000 images. So it just shows the amount of effort that we had to go through to achieve that. So why is that? You know, surely if we'd identified 187,000 images, we could have just used a data image repository of those images. Well, it's never so simple. For the individual defects we received, we realised that when the person doing the survey stops the camera and records that defect, there may be a point where the actual image of the defect was missing, or was slightly before, or there was a better image slightly after. So we split the data and the images into 5 different images. So we captured the actual time from the video recording, and then we captured 2 seconds before, 1 second before, and then 1 second after, and 2 seconds after. And by doing that, we hoped to capture the clearest, sharpest image of that observed defect. And this came out of some discussions we had some of our partner companies who'd actually been working on that. So Welsh Water flagged this up as an issue they'd had when they were looking through this. So we tried to solve this problem. So that was lessons learned by engaging with our partner companies. So that was a really benefit thing to do. Hence, we then created our repository of 726,000 images. Well, I love looking at video of CCTV. As people know me, I'm a bit of a geek about that. However, I was never going to be able to sit down and go through all of those images myself. So we had to incorporate the whole team at WRC. So that included up to 15 people who all needed training in CCTV image recognition and defect classification. So that was quite a complicated process. A lot of these people had never looked down a sewer pipe in their lives. So to bring them up to speed to the required standard was quite an involved process. So we captured the image, as you can see there in the screen, and we also had a bespoke app that the people looking at the image could not only see the image itself, but they also had all the metadata. So all of the XML data that was transferred through, and this told them that they were looking at a particular defect. So that was named, the meterage, the clock reference of where the defect occurred, and all the other required information. So categorization, quantification, etc. was all captured within that one image. Rather than just looking at a picture themselves, these were inexperienced people having to be brought to speed. So they were trained, they were coached and mentored, but this was a means of accelerating their development process. So they could recognize the defect they were looking for. Did it meet the required standard or specification set out in the MSCC? And could they accept that image? So what did we need? Well, each of the images were obviously assessed for accuracy. As we know, sometimes CCTV coding is inaccurate. Some of the water companies report that 30% of their data is accurate, which is something we had to overcome. So assessing each of the images was important to correctly assess it and accurately describe it. The metadata itself had to be amended where necessary, and identifying image data was also required to be done. So each of the images typically has the site location. So we had to remove that from the image repository because obviously there's data sensitivity issues. We also had to remove duplicates images. So we had several times where duplicates appeared and with those had to be stripped out. And we, having had discussions with the AI vendors, the optimum level for the algorithms was around about 1,000 images to be stored. So rather than collect multiple thousands of images of a crack or a fracture, we had to sort of settle on around that figure. So once we hit that sweet spot, we stopped it for those particular defects. The metadata, as we said, had to have the correct defect code, and we had to change that where required, and it had to have the necessary defect location, etc. And we also populated any missing fields. So to summarise, the images had to contain the defect that we were looking for. The image itself had to be facing down the pipe with the pipe centered in the frame. This is what the algorithm is looking for. They can't associate or benefit from pan and tilt, etc. and the defect or the pipe, the defect in the pipe could not be obscured, so with text or whatever was in front of the screen. So it was important to do that. And then we could, so some of these are some of the examples of where we had to reject images. So poor quality data, the image on your top left-hand side there is blurred. It's also facing to the side of the pipe, so that wasn't acceptable. If we can't understand what the defect is, then how can an algorithm? So we had to be very ruthless in terms of that. We also had to check that the camera positioning was correct. So as every CCTV operator knows, the camera has to be centralised, looking down the pipe. So we had to make sure that was done. We had to reject all pan and tilt images, and there are a lot of those. So that had to be removed out of the data set. And where intrusive text was overlaying that, we didn't want to obscure or give the algorithm sort of grounds for not accepting that data. So we had to go through that cleansing process, which was quite complicated and intense. So we had to do, as with any CCTV inspection, you have to do good quality QC. So whether that's Kieran's teams out in the field for UU, they have to have their data checked regularly to make sure the accuracy of that data is good and can be accepted. And then we had to do that for our own processing as well. As we've said, we brought people from 0 up to operator level quite quickly. So we had to make sure all of the QC work was done to make sure there was a good level of accuracy amongst the data. So we checked that. We checked all of the files. If we had a failure rate, we went back and looked at the whole folder again. So that was repeating work, but we felt it was really necessary. This is, as Kieran said, this is a global first. This is the first time anybody's done this around the world as an open data source. So we want to make it as good as possible. So that was one of the processes we had to do. So the breakdown. Well, we anticipated, or I anticipated, with many years of experience of doing CCTV surveys, we weren't going to get all of the images, all of the defect codes populated with quality images. They just don't exist. The coding structure is set up to code the art of the possible, so we weren't going to get all of those defects through. So we worked our way through, and this is the breakdown of how many images per code were found. So we got 17 up to the 1,000 mark, but as you can see, there is quite a tail off towards the middle section, but with some of the more obscure defects only getting a relatively low number of images. Now you may say, well, that's pretty meaningless. It won't be able to train. Well, having had discussions with the AI vendors, even having some data means they can progress. Ideally, they would have the 1,000 figure, but any data is better than none. So if you're entering into this market as a new supplier, having those data sets, having that ability to code the more obscure defects really accelerates that progress. So ideally, would have got everything up to about the 1,000 mark, but you know, we have to deal with what we had. So yeah, looking at that, so in total we got to 72 codes with data. I think the full coding structure is around about the 300 mark. So yes, we were up against it. We had to deal with the data we had. There are grounds for improvement, and we will be looking and speaking with the industry to see how we can progress that and accept more data and get that data set improved and increased in its scale. So the ones that we were never going to achieve. So things like weld failures. Well, I've been coding now for over 15 years. I know don't look that old, but I am. And weld failures, well, they're just not there. I haven't seen one. So anybody out there with pictures of weld failures, do send them through to WRC. We will try and incorporate them. Things like ingress of soil, dropped inverts, fracture radiating. Well, fracture radiating, that stems from the fact that that is a relatively new code to the UK. So we were using historic data. So the code fracture radiating, it may not be there in large numbers, but it's unlikely to have been coded by many of the previous surveys. So going forward, future-proofing, improving the data set, we could start to accept more and more of these newer codes that are being brought in. So that's some of the inevitable missing sections that we had to accommodate with. Just wrapping up, obviously, every time you look down a CCTV, with a CCTV camera down a sewer pipe, you'll always see the strange, you'll see the wonderful. You'll also wonder, how the heck does a tyre get into a sewer? Or how does that fork stand up in a joint, etc. The two eyes staring at me, Wally, in the pipe, don't know what it is. It's very strange, very peculiar. And then the bottom image there, we had a bit of a discussion in the office around this. We think it's the cap from an interceptor. So that's, we had a bit of a debate about that, but that's what we settled on. So yeah, so just a little bit of a fun aspect. The team took a lot of joy in flagging up these weird and wonderful things that we identified. And you know, it sort of brought a bit of lightness, brevity to what was quite an intense coding process. So right, so I'm going to hand you over to Justine, who project managed the project.
So thank you, Pete, for that. So yes, as you said, I'm Justine Better. I managed the project, which I've definitely learned a lot through this. My background is not in sewers or coding or anything like this, so I've learned a lot through it. Kind of worked closely with all the project partners, as Kieran covered at the beginning. So we've completed the project, we finished getting everything together, and then we had to think about, well, the adoption planning. But we didn't think about that at the end. We made sure that was one of the really early thoughts as part of the project. So an adoption plan was produced, and this was done prior to any of the data analysis. And so the idea of that was to ensure that the final data set kind of fit what the requirements were. And what the industry needed. So the main areas in which water companies and the different AI vendors flagged as where this data set would be most used is around the training of existing AI models, validating them as well, and then also evaluating how well they work. So it's improving what's already there. But also this will enable water companies to do it both themselves directly, so create their own models, improve the ones they have, but also working with suppliers and AI vendors to ensure that all the models that are being used are using this data set to improve the validation of the models, and so they're as accurate as possible. I think all of this, working with the different vendors and working with the water companies, it really re-emphasised the importance of this data set being open source. Kind of the part of the adoption, it made you realise how many different parts of the industry really need to use this in order for the benefits to be fully realised. And so in order for this to be best, we want everyone to go out and use it. We want everyone to download it. We want kind of suppliers to use it, contractors, water companies, everyone to access this data set, download it and use it to train models. I think as part of the adoption plan, there was a significant emphasis put on what were the challenges, what were going to be the challenges to using the data set at the end, because unless we really understood where those barriers were going to be, we couldn't plan to overcome them. So I think the main part of that was around the size of that library. So being able to download it all, being able to store it in a place where everyone could access it. It's almost the access to the data set that was going to be the biggest hindrance to it being used. So that was why we've partnered up with Spring, and we've had conversations with Stream as well. And so the opportunity to use the platform like Spring to host the data set will enable everyone to be able to access and download it. So I think from the start, it was very clear that everyone was so keen to have access. Everyone could see the benefits of having a data set like this. The main barrier was just around the access to it. And also alongside that, so once everyone's got access to it, there was obviously the queries that Pete brought up earlier around the having enough images. So everyone we spoke to said 1,000 images per defect was really key. However, obviously we couldn't do that because in some cases the data is just not available. There are not the images available. And so really to maximise the adoption potential into the future as well, we need to look at what's the continuous development and is there an opportunity to continue adding to the data set as well. And there were also queries around what was the opportunity to using short video clips as well, because obviously when you run CCTV footage through an AI model, it looks at far beyond just one still image. It has the movement and all of that. So, however, that's then brought into the whole digital size of the library. And so I think that's a challenge to look at the future, but there's definite opportunity there. So this project, it has gone on for, I think, over 2 years now. So we have, I'm so pleased that we have come to the point where we have successfully developed the image library to act as that single benchmark data set. I think at points it didn't feel like we were ever actually going to reach that point. However, everyone has pulled together and has done that. So I think, you know, the 7 project partners, we have over 27,000 images that we've managed to pull together as part of this. And then now that we have that, we will be able to, that can be used and added to and become a base that we can then build upon into the future. But I think as part of this, there were several things that really were emphasised throughout. And as Kieran said at the beginning, there was a lot of lessons learnt that we have looked at. We've had a lot of reflection as part of the projects. We did a big lessons learned session with all of the project partners, as well as with ourselves at WRC, having a real look at what we thought were some of the key things. And so I'm going to try and summarise some of those now. So I think consistency. It was always going to be a challenge keeping the output consistent. We had 15 people doing the validation of images. So kind of having a bespoke app being built, that was so important in order to ensure the output was consistent for every image. Because obviously, if that output isn't consistent and the images and the data set aren't consistent, then companies and the AI models may not be able to process all of the data. So developing the app, the validation and quality checking protocols that were put in place to ensure that consistency were really, really emphasised as important. And obviously now that those are established, in terms of building to that data set in the future, we can continue to using those protocols that have already been built. I think it's been clear through this. So collaboration has been key. There's been so many project partners throughout this, and we couldn't have achieved this without working with each individual partner, getting the data set, getting the data downloaded. It was no simple thing. We had data transferred through Azure cloud to cloud transfers. We had OneDrive transfers. We had data collection directly from storage accounts, and actually having that collaboration with the companies and with the different leads at the different companies has been so important in order to get this project completed. I think additionally, as part of that, there's been a lot of changes in roles within the different partners. We had different plan at the beginning, and I think we came down to about a plan D in terms of delivery. The plan had to keep changing because we didn't quite understand how each partner was going to contribute at the beginning planning stages of the project. And I think we had ideas in each company. You have those ideals, and you can be quite idealistic about how everything is going to go. But when it came down to the reality, it was a challenge in some cases to fulfill the roles by no fault of any individual person, just due to other constraints. And so really we should have, at the beginning stages of the project, really spent time defining what those roles and responsibilities of each partner should have been. In terms of, I think cybersecurity was a far bigger barrier than we ever thought it was going to be. Obviously now with hindsight, it's obvious that with an open data project, cybersecurity was going to come into it. However, it was a barrier to the transfers at the beginning. It was barrier to the storage of the data in the middle of when we were doing having the 15 people all contributing to the same data set. And then also it was a barrier to publishing. So we really needed to work hard to get a good understanding of all of the different cybersecurity requirements. And again, I think if we had realised at the outset of the project what a challenge that was going to be, we would have done it a lot earlier. Data quality is one that's been touched on by Pete and also by Kieran at the beginning. So the quality of the footage was a challenge. If there was data, well, you could see the volume of data that ended up being rejected just from the quality. But if you had blurry images, if the footage was facing slightly the wrong way, but also if there was text written over the top of it. Now, quite a few instances where the entire image was fully covered by the text of what the code of what the failure was, but you couldn't actually see the failure through the added text to the image. And so also on top of that, so you had the visible data quality issues, but also with the metadata, if something hadn't been spotted, obviously the way that we spliced the footage was where something had been recognised within the footage. It took a still image at 5 seconds, 2 seconds before, 2 seconds after, and the second of. But if there was no recording against that specific time, then the footage wouldn't be spliced. So there probably were some patches of the footage that we haven't got the individual, all of the defects for, just because they weren't spotted or they weren't already included within the XML. And so the way that we spliced it, it wouldn't have picked them up. And finally, intellectual property. So that is something I had no knowledge of prior to this project. It's not something that I would ever say I had a desire to become an expert in or really know much about at all. However, through this project, I have learned a huge amount about intellectual property rights. I don't think anyone realised the challenges we were going to face. It was probably the main reason for delays in the project and some of the main challenges, really, because as soon as intellectual property comes into play, you have the legal side of things, and legal problems are not the simplest to solve. So it ended up being a lot of sessions with big groups of people in meetings and trying to work out the best way forwards. Both intellectual property rights of, if, for example, it was more the background intellectual property rights, which were a challenge to do with the original contract through the Ofwat fund, which has now been updated for the later competitions. So I think it was things around the intellectual property rights and kind of having everyone coming together, all the project partners, having the legal teams at different water companies, everyone did come together to overcome them. But again, I think we were potentially slightly naive at the beginning, not considering that that was going to be a significant problem in the project throughout, given we were hoping to use initially one of the project partners to use some of their own, they had a process in which they spliced the footage themselves, and we were hoping to use that. However, by them using an app that was existing, it pulled into the intellectual property rights of that. And then further on, other companies wanted to try and help. However, they couldn't because of their intellectual property rights. So yes, that's definitely not something to be looked at lightly. So as part of the project, we did a score at the end of it. So looking at the strengths, the challenges, the opportunities and the risks. And so I'll try and cover some of these. We've got a lot that are listed. But I think obviously collaboration. This project, the collaboration has been brilliant. Yes, we've had our challenges. We've had the intellectual property, we've had data transfers, we've kind of been through a lot of different barriers. But the one thing that has never stopped is the desire of each partner to want this to be a success, and bringing all of the necessary people to the meetings to ensure that those barriers are overcome. So I think the collaboration that we've seen during this project has been one of the massive strengths. And I think the enthusiasm, yes, it goes without saying, it's been brilliant throughout. In terms of communications, I think with a project that goes on for 2 years and we've had a lot of challenges and barriers, there have been patches where the communications, the engagement has been a challenge. It's engagement reduced over time. I think it's something that's quite common. It's definitely not only in this project that it's seen. I've seen it in many other projects as well, but it was definitely something we had to overcome. I think it was just a case of, as you started realizing it was happening, bringing it to everyone's attention, reminding everyone of that common goal that we had, and then everyone was back on board. I think it was never anyone pushing against it, and never anyone trying to stop communications. It was just a case of, with time, it's always going to be a challenge. And I think the communications with Ofwat, Kieran mentioned it at the beginning, we worked really well with Ofwat. We kept them up to date with everything that was going on. And it's been fantastic because they've seen the benefits, and they've seen the benefits throughout, and we've had some really good feedback on some of the lessons that we've submitted as well. So I think communications have been a challenge in some cases, but actually it's probably been one of the massive strengths of the project. Obviously collaboration, we've touched on that, massive benefits to the project. Where we've had some of the delays caused by a number of things, I'll touch on those in a second when we go over the challenges, but we've had to replan delivery repeatedly. And so actually we have managed to deliver the time to the rebaseline timelines. We've delivered it to time and to cost and to quality. So that's something we can be really proud of. We were able to be very flexible with delivery. So having the 15 different people doing part of the analysis, as well as getting input from project partners and the AI vendors to be able to help with some of those key delivery decisions that needed to be made. That's been a massive strength. So I think probably that summarises a lot of what we have experienced strength-wise. I think challenges, as expected, there are quite a few challenges, and we've tried to be quite honest here, and I'm going to try and do an honest summary of the challenges we faced. So right at the beginning, coming into just getting into contract, it took us about a year. It was originally probably the wrong contractual approach. However, that was later corrected, and now we have a format of a collaboration agreement which everyone is happy with. So actually, yes, it was a massive challenge, but it was a brilliant strength at the end of it, that an opportunity, because we have an approach that has already been adopted into other collaboration projects. Project planning, this is one that I've had to stick my hands up for, in terms of at times we got a bit ahead of ourselves, in terms of you always want to get straight into the delivery of the work. We wanted to get into the data analysis. However, we later discovered that there was a patent that existed that we weren't aware of. And so as part of, if people are looking to use this data set, or maybe start up a new company or something like that, do your due diligence. There are patents operating in the field. It was something we wish we had probably discovered a bit earlier. It may impact some of the adoption from how it was initially seen. However, I think there's still brilliant opportunity and for adoption, and it will definitely be used well. The data set will be used well within the industry. The data hosting wasn't in the initial scope. We didn't have a plan. Possibly, again, slightly naively, we thought, oh, we just need somewhere to host the data set. However, if it wasn't for Spring and for Stream, which have kind of started around the same time as this project, we wouldn't have had anywhere to host data where it would have been accessible for everyone. And so that was a major challenge, was coming up with where it would be best to host the data set at the end, because there haven't been open source data sets produced before across the water industry. It's not something that's been widely done. So there weren't the existing places to hold that data. So some of the communications, I touched on it previously, with although the collaboration, the communication, some of it was a massive strength, there were large challenges. Some of the engagement reduced at certain points. The communication around probably the data transfers, because there were so many, we were looking at 7 different data transfers. Each were going to be done in different ways. We had the data transfers by cloud to cloud Azure. We had OneDrive, data collection directly from storage accounts. All of these different ones, they had different people working to get those going. And the communication on and expectations of where each of those weren't always clear to all project partners. And then around when there were challenges and problems, the internal escalations within companies sometimes cause further delays. So that's always going to be a difficult one. Once things get escalated, it's always going to take a bit of time. And I think towards the end, we were able to we saw challenges, we discussed them really well, and we came to good conclusions that everyone was happy with. However, earlier on in the project, we would tend to go towards escalation first, and sometimes that did cause further delays. We tried to keep the technical updates separate from the more management of the project board. We kept them very separate, which was done on purpose so that you had real focus in each of the sessions. However, there was a bit of not a miscommunication, but just a lost opportunity to have that overlap between the two groups. And I think if we were to do it again, we would have a technical update in each of the project board meetings, and probably have an overall project update in each of the technical meetings, so that everyone had a clear aim, and everyone had the same aim in mind when we were trying to make the different decisions. So meetings, I touched on this before, so the levels of engagement. I think the data transfer and the contract issues, they went on for over a year for us to resolve that. So meetings dropped off in that time because there wasn't much else to discuss. And so then when everything started back up, it meant that where at the time at which the project first started, partners had lots of time and to provide and to give to the project, they didn't have that time when it came to the delivery. So there was unequal support given between partners, but there was never any unhappiness or anything like that between project partners, and I think that's where it was actually a really good team working together. So a few more challenges around decision making. Probably we needed a firm stance at board at times. So I think that's where I said sometimes we would escalate quite quickly, whereas if we just made a decision within the project board, it would have prevented some delays. So that's around, the bureaucratic processes. But sometimes you just need to think, is it actually relevant to the project, and keeping that in mind, and is it a board matter? So something to take on. I think personally there was quite a tricky management dynamic. So where WRC, we were in charge of delivery, however we had little authority. So where could we push? For example, if there was a delay in receiving data, where could you push? But also we couldn't do anything about it. So it was quite a challenging dynamic to manage. And so, I think that leads into the lead partner versus the board sometimes wasn't clear. So what powers did Kieran have as the lead project partner for United Utilities? What did he have that on behalf of the board, and what needed an overall agreement across the whole project board in order to make a decision? We tended to go with the majority vote, which made sense, but sometimes you thought, I know that you get the view that everyone's going to have the same idea. However, you didn't know whether Kieran could make the decision on behalf of the board or whether it did need that majority vote. Data, I touched on this before, or the data transfer was a challenge. However, it was also raised and quite clear through this that access to data for water companies was also quite a significant challenge, and probably something that wasn't foreseen before the project and when everything was starting up. So some companies didn't have access to their own data, so it would be managed by contractors, and so then being able to extract that was really difficult. Or if a contractor was busy doing something else, it meant that they couldn't have the quick access and the quick turnaround. So although initially we were looking for a terabyte of data per company, I think we only had a couple of companies where we got the full terabyte, and others we didn't get that volume. As part of the transfers, especially the Azure transfers, I did not know much about Azure and data transfers before this, but this is something I learned a lot about. But things like the file location and the length of files names cause files to get corrupted on transfer, which wasn't something that we saw coming. And with the quantity of data, sometimes it was too much, sometimes it was not enough. And having communication between the specific IT partners within companies and between partners became key to sort that out. Adoption, I think I've covered that. So how we would like it to be done. However, we don't know if that is exactly how it will be done, and it's really difficult to measure that. So how are we going to know how many different people use the data set? How do we know how many times it will be downloaded? And if it's downloaded, how do we know it's been used? Or has it been used and made a difference? That's something that's really tricky to measure the benefits of. So more positive, so the opportunities, I think it's clear there are loads of opportunities to do with this data set. So we can review, and as an output of the project as well, not just the data set, but also the learnings that we have made from the project. So things like the collaboration agreement, we now have that to use in the future. So we know how we can get into contract more easily on collaboration projects, but also there's almost a structure for where you can produce an open data set, where it can be stored. And so now that we know where the open data can be stored, and we can hopefully provide enough details through the use case that is hosted on Spring as well, where we've got some of the detailed learnings from the project. They can be applied to, directly to other projects, but also have already been applied where project partners have been involved in open data projects since. So the obviously major opportunity is the use of the data set, so having a greater understanding of AI's model performance. So now, whereas previously there wasn't this single benchmarked data set, now the uses of that, it can be used to, as well as to validate and improve data sets, it can be used to evaluate how well they're working. So there's opportunities there to almost start measuring the accuracy of the different models on the market. So that's a really good opportunity. New suppliers can be approached to use. And so it really opens the field. But again, this is where just make sure we need to do the due diligence around the patents in the field. But yeah, there's massive opportunities for new players in the field to use this data set and improve and increase the competition within the market. Obviously working with Spring to showcase the project and Stream for some long-term storage, that's a fantastic opportunity. And so we can then keep in touch with them and keep the data set growing, and that is something that we are keen to do so that it continues evolving and there's that continuous improvement. So risks. I think there's been quite a few risks associated with this project. The delays that were throughout, they almost put a stop to the project. So through delivery, as a result, kind of delivery timescales were compressed for the getting the data set together. So that's where you had the 15 different people. As soon as you had the 15 different people doing it, you then had the risk of the lack of consistency. So actually, although that these were risks, it led to some real strengths out the back of it with some of those quality processes that are now in place. However, there was a significant risk that Ofwat could have closed the project early due to slow progress, and we would never have produced the output. And I think, as mentioned with the lack of engagement in certain parts, where there were the delays, the project then lost momentum. And so as a result of that, maybe those project partners may not use the data set as much as we had initially hoped, although hopefully that's not going to happen and everyone will use it. I think then the main other risks were around the IT security. And so we've had to remove any, it's the GDPR side of things, so making sure that any addresses have been removed from the data sets, and that the data set is available and has the level IT security, cybersecurity and storage. I think the addresses was a particular worry around particularly the publicity side of things. I think the water industry has enough of a challenge as it is without someone being able to download a full data set with names, locations, and look how bad the poor condition the sewers are in X area and Y area. It's just not something that's required. So the removal of those addresses will prevent that. However, there is that risk that even if without the names on there, could pressure groups access the data to provide some bad publicity. I think that is a risk. However, the opportunities definitely outweigh the risk and the opportunity for improvement. And yes, the adoption side of things, how do we know that what's being published is used and how can we track the benefits? It is a risk, so we don't know if what we'd planned at the beginning is what's happened. So in terms of the further adoption of the data set, we've touched on this before. So looking at the continuous development to maximise the use for AI training. So can we grow the data set? Also, is that opportunity for the short videos instead of just the still images? And is there any way that we can continue to learn and come up with methods? And finally, so where can this data set be found? So obviously we have completed this project and it is now hosted on Spring. So if you log into Spring and register, and under the Knowledge tab, you will be able to find the case study and the data set. So all of that will be there and available to download. We're going to go for a break in a second, but I know that Kieran wants to touch on something. So I'll pass over to Kieran.
Thank you very much. That's really, really brilliant. We've managed to get through all of that. I just thought before we go to the break, which gives you a chance to think of what you've just heard, maybe think of some more questions, and then when we come back, between myself, John, and Peter, we'll try and respond to those questions. I can see that there's been questions already in the chat function, and I'm noticing a trend in lots and lots of questions about artificial intelligence. And it's worth me just setting the scene one more time, what this particular project was all about. This particular project was not about artificial intelligence. It's not about creating an artificial model that anyone can now tap into and it will automatically do all of your CCTV analysis and defect classification and coding. No, this is the publication of a data set. And so we have some idea about what people might do with that data set. Companies who are already mature in this space, already using data, they're probably going to take this new data of a size and scale that they've never had access to before, and certainly not of a high integrity cleanliness level. We think mature companies will take that information and simply supplement and add to what they already have, whether that's a water company with their in-house teams, their in-house operations and models, or whether it's, for example, a third-party vendor, an artificial intelligence provider. We think they will take this data and they will add to their already existing models. Of course, we also know that some water companies have not yet taken the plunge into this digitization space, and maybe they've been held back because there isn't enough data for them to do this on their own or to take the action that they're really looking for. So we're hoping that people will take this information and use it for the purposes that help and benefit them. Collectively, then, we get a sector-wide impact. The project team in its original design of this scope had some thoughts like maybe someone could take this data as open data and give us some insights and analysis that we've never been able to spot before. Maybe we might get some new service offers. Maybe someone can use this data to generate a brand new service that we've never seen before. We don't really know where people might take this data and what beneficial services and products we might get as a result. So we'd love to hear your thoughts. I would encourage you to post in the chat, what do you think the benefits of this data set are? Where do you think developments might come? Ongoing developments, where do you think this should be built on and expanded? We've published all of this amazing data today, but of course, maybe it doesn't stop there. Where else should this go? But just to summarize, this is not an artificial intelligence model being published today. It's a clean, high integrity, high volume data set. And I hope that helps you think about the questions during the break. Chloe, back to you. Thank you.
Perfect. So thank you guys for an amazing presentation. That was really, really great. I just wanted to kind of take this chance now to answer a few questions that have been coming through the chat as we've been going through. Just double checking that Kieran's with us. There he is. Perfect. Okie dokie. So first one on the list was from Clive. It says, Kieran mentioned CCTV trolleys being used by people. I take it these are always remote controlled by a human as opposed to being autonomous. Just checking. I think that potentially is a Kieran Peter question.
I'm happy to step in.
In the chat, Clive's right. Yes, we're talking about humans deploying the method of collecting the CCTV footage. Could be a handheld device, it could be some sort of trolley system. So yes, definitely human deployed guided. Although I do mention in the chat, while in parallel, there are some innovation developments being developed centrally. It's all about robotics and automated systems, so watch that space too.
Yeah, there's the PipeBots project that looks at putting camera system or inspection systems down pipes and being able to track the flows, etc. And also systems that you can launch into a sewer pipe and then collect. Obviously, that overcomes some of the issues around large diameter sewers, etc. We see the coding aspect being applicable in all cases on that. So I think it's marries up quite well with all of those aspects.
Perfect. Thank you, guys. And Harry asks, how many types of defect types are there?
Good question. I haven't actually counted them all up. I think we know there are around about 300 plus, but when you add in all of the different permutations, you then start to exponentially grow that. So there are 300 codes, of which we managed to classify 72. But as I mentioned, many of those are to cover the art of the possible rather than the art of or what is often found. So we had a bigger preponderance of defects that are commonly found, and that's something we need to overcome going forward. Yeah.
Perfect. Thank you, Peter. And also, I think this is another one for you. Harry asked, have you aligned these with the current sewer condition assessment standard?
Yeah, all of the codes were classified as according to the Manual of Sewer Condition Classification, MSCC, to those in the know. Yeah, the 5th edition. So yes, that was one of the steps that we made sure that was done. This is primarily focused initially at the UK market. We are in discussion with European and American partners about potentially opening it up into using other coding structures where we could potentially deploy this. And some of the vendors that we have spoken to, they do operate outside of just the UK. So we are conscious that we would like to expand it into European and American coding structures, potentially others as well. So if anybody wants to come and have a conversation with us, that's something we'd love to explore. Yeah.
Perfect. Thank you. And so another question from Clive was, you mentioned some people doing the AI on the CCTV footage. Can you name them? Also, did you find many organisations capable of doing that, or was it a no-brainer?
There are existing AI vendors who are supplying CCTV software. I'm sure if you did a Google search, probably best not to name them for favoritism, etc. But yeah, there are probably around about a dozen existing companies, of which we spoke to around about probably half a dozen. They are American, Australian, European systems, and obviously then in the UK. So yes, there are several in there. I don't want to name names now. It's probably best not to.
Perfect. Thank you, Peter. And a question coming in from Harry is, what is the approximate cost of the new process versus existing cost using existing techniques?
In terms of the coding, we see that as reducing some of the, as Kieran outlined when he was setting the scene. A lot of this work is labour intensive, be that within the surveying companies or within the water companies themselves. So we see the AI as doing some of the heavy lifting, identifying the more routine, the mundane, We still definitely see a role for qualified, experienced engineers to identify features that the AI hasn't had the opportunity to see. So there will always be a role for the human to interpret and to identify those weird and wonderful anomalies. However, with the AI improving, we definitely see it will take over some of the more mundane tasks. And having done many hours of CCTV coding, staring at a blank pipe, doing with very little to report, I think that's where we will definitely see significant improvements and cost savings for the industry. Yeah.
Good stuff. Thank you. I think the next question from Nicholas goes back to the conversation Kieran had about AI, but please let me know if there is anything else, Nicholas, that you want explaining. So Ian has said, as a next step, are you exploring federated learning to improve the data models?
I'm a bit beaten by federated learning.
Yeah, I think I am as well.
Yeah,
I think it's linked to thinking this is about AI again. This is about publishing a data set. Okay,
thanks, Kieran. That's great. And so David would like to say that the benefits from using an open source data here is a powerful proposition and a great offering. So great work, guys.
Thank you.
Anthony mentioned no mention of continuous defects. I'm wondering how you classified and made use of these for the ML training data.
Yeah, we because we work from an image, obviously classifying continuous defects isn't possible because obviously that's a continuous defect is where it stretches beyond a meter or is repeated. So there was no means of doing that in the data set. And with AI as well, they haven't progressed to that level. So it will be coded on a meter basis. So the AI, there may be some sort of data merging at a point, but within this data set, we couldn't accommodate continuous defects. No, something we need to look at.
Thanks, Peter. And so another question here was, what new foreground IPR was produced by this great project? Who owns it, and is it freely usable by others, or is there a reasonable royalty license fee to be paid? I think that's for you, Justine.
Yeah, so the data set, that is the kind of foreground IP that's been produced here. So the data set, there's no fee to use it. It's you just have to sign up on Spring, register and log in and download the data. It's covered by an open data license. No royalties to pay. So yeah, please go and download it. Please use it. Maximize the use of the data set. I think that's the key message from us.
Definitely.
We've tried to make it as available and open and as easily accessible as possible. So
perfect. Thanks, Justine. And so Anthony asked, does the image library include the XML as well?
Yes, so the images that will be able to be downloaded, and that's either as a complete download, will include the metadata or the XML data for each of those images, because it's important that the AI software can pick up that feature. So something's appearing at 12 o'clock, that is recorded and is encapsulated within the download. So yes, that is included, and it's done per image, rather than as two different downloads.
Amazing. Sorry,
I was just say, so it's not a separate XML file. It's just in the metadata of the images.
Fab. Okay. And so there's a question from Christopher Hamill, which I think is actually aimed at Spring, which is due to the size of the data set and the concept of the collaboration and open source data. Has Spring considered a technical solution to store and facilitate the use of these types of data sets by all involved? So I think in answer to your question, Christopher, I'll take that back to the team and we can speak further with WRC about the future of hosting the data. Perfect.
Kieran's got his hand up.
Oh, sorry, Kieran. Hello.
Yeah, thank you very much for that. I'd remind everyone on the call of the separate called Stream. Stream, yes, of course, is has the specialism around storing data sets and making them available to others on behalf of the sector. So I really think we should, yes, receive that question today, but find a way for Stream to respond to that question. It's clearly going to be a Stream type dilemma for the future, and they've already started thinking about things like that.
Yeah, I was going to say we've had continuous conversations with Stream throughout. I think my last conversation with them was with Melissa from there was last week or the week before about hosting the data set. So it's something they're aware of, and we're going to work with Spring as well, so that it can get moved across in time.
Perfect. No, that's thanks, guys. That's great. And so Harry's asked, once you have all the defects recorded, does the system actually come up with a sewer condition grade?
Well, I think what we're providing is a library of images. We're not providing an algorithm or a software package. That was a conscious decision made from the start that although my managing director was quite keen for us to come up with a solution, this was very much about opening the door for anybody and everybody to utilise this data. We recognised that the data was the blocker, and by providing this data source, we could do that. The coding software or the algorithms used, it is really for them to produce the level of reporting and defect grading that the industry requires. So that's something they'll work closely with. So yeah, using the WRC SRM scoring system, which is widely used in the UK to assess the condition of sewer pipelines, that is something that the software will need to address. Yeah, certainly.
Amazing, thank you. And another question from Anthony here was a question to WRC. Any thoughts about taking this to other standards? They've put in here NASCO, EU, WSA.
Yeah, I think we just touched on that. Because it was an Ofwat funded project, we originally have focused purely on the UK codes, but WRC are very closely linked with NASCO in the United States. We're also involved in obviously European standard groups. And I think the potential, because of the a defect is a defect, the coding or the coding of that defect is dependent on the standard you use. So there is nothing to stop us other than time and resource to make it available as for example, a European standard code or a PACP code or an Australian sewer condition code. So that is something that we could look at. We'll need to talk to our partners how do we achieve that, because obviously using NASCO standards, they own their coding structure, so we need to have those discussions with them.
Fab stuff, thank you. And so Nathan put in here a comment just saying to Justine, sorry for some of the IP issues, but I think Kieran did expand on that a little bit in the chat, but I don't know if you've got any further thoughts, Kieran.
Yes, so it's we've dwelled a little bit on intellectual property. I think I'd just like to take us right back to remembering when we first started all of this. The Ofwat fund, contractual rules, bids, the maturity of water companies making bids, defining scopes and those kind of things. In the last 4 years or so, we've come on light years in this respect. The IP matter that we're talking about is along the way in the project, we realised that we hadn't taken full account of all the intellectual property that were there. Potentially, intellectual property in some parties may be prohibitive in what we're doing. We had a long old chat about that, a few workshops, some discussions internally as individual partners and collectively as project teams, and then with Ofwat ourselves as a collective. It became very clear, actually, that intellectual property doesn't hold us back in delivering this project and never did. So we're pleased to say that it didn't hold that up. Remembering, Peter said a minute ago, this is about a library of images, a data set. We're publishing it out there freely. In the aspiration that other people do something with the data. Now, of course, in terms of what people do with it, that is then your obligation, your responsibility and accountability. So please you must take full account of what intellectual property exists. There is none in our data set that would restrict you, but there is other matters out there that you do need to take cognizance of, and that's for your duty to do, that's for your responsibility and your accountability. So in terms of the intellectual property, we dwelled on it a little bit just as part of a project learning, really. Positively, Ofwat responded to us discovering this, and they've converted that dilemma into real positive action in how future bids are made. They insist now that there is much more searching done on other market-ready products that might be there and other intellectual property that pre-exists that might slow down, stop, or even absolutely prohibit any of the bids that we might ever make. So I think the dilemma we faced, we dealt with well. We published the data set with not all this into much more positive action for the future.
Thanks, Kieran. Sorry, we lost you a little bit there at the end. So another question coming in from Clive is, in terms of key/most important deliverables from the project, did it just deliver a repository of images of defects that can be used by AI companies to automatically process the footage and identify them, or did you also teach the machine to identify those defects in bulk too? I think, Kieran, again, you expanded a little bit in the chat on that, but I don't know if you've got anything else to say on that.
I think with our words earlier and Peter's words earlier and my response in the chat, I think we've dealt with that query.
Okay.
Peter, do you have anything in addition, though?
Yeah, no, we haven't been involved in the training. We didn't see that as our speciality. There are some incredibly intelligent innovators out there who can move artificial or defect recognition forward at a far greater pace with greater accuracy than WRC or any of the water company partners, I would suggest. So the aim was really just to provide that data pool that they can utilise, maximise, and then hopefully go forward and accelerate any developments. And we really saw that as not being the next people onto the gravy train, so to speak, but to accelerate development and innovation in the space. That's hopefully what we can achieve, and we'd love the feedback on that as well, Ian.
Perfect, thanks, Peter. And so another question from Martin was, have the organisational lessons been embedded into a standard contract for future Ofwat innovation projects? I know you touched a little bit there on Ofwat.
Yeah. So, I mean, getting the collaboration agreement together at the beginning, I think, yes, it was a challenge, but it's actually, I think, probably alongside the data set, one of the biggest strengths and outputs of the project. So Kieran at UU, it's worth really stressing how hard the legal team at United Utilities worked to get a format of a collaboration agreement that people would agree to, that would enable different annexes and additions to be added on, which can be tailored to suit the requirements of any future projects as well. And I know it's something that United Utilities have since used for other projects, but yes, it's definitely something that has been an output and can be used in the future. Kieran?
Let me just build on Justine's words there, because I think it's worth very early project in Ofwat funding arrangements, so we were all learning as we were going. We are light years away from that immature state these days. Water companies do collaborate more with third-party partners like WRC more routinely. What I can comment now is that the new collaboration agreement does a thing for us. Firstly, it builds on the strengths of this project, so it reinforces that we need collaboration and strong collaboration behaviour. It definitely promotes knowledge sharing, so the agreement talks about the demand to share, which is a key requirement of all of this. It definitely encourages more and stronger frequent interactions with Ofwat, which I think was one of the strengths of the team, was our dialogue, our open dialogue and honest, authentic chats with Ofwat about how this project was processing and the speed, and how could we unlock some of that? And really the collaboration agreement builds on this in terms of, you know, encouraging that agile environment. The contract, the collaboration agreement has some very specific clauses in now, including intellectual property, including how to deal with project delays or a partner, you know, thinking that we might deliver a particular work stream in one way, how might you switch and pivot and do it in a different way? And the collaboration agreement, and in fact Ofwat's winners agreements, which kicked off the process, we're all clearer on roles, the role of the delivery partner, the role of the lead partner, the role of a steering group, a project steering group versus a technical steering group. All of these things are miles more mature now. Outside the collaboration agreement, of course, the issues that we faced here about how on earth do we transfer data? How do we store data? Where the hell are we going to put all this data? That's Stream's remit now, which did not exist at the time that Peter, Justine and I and the project team all came together. So that's moved on as well. And I think generally there is more emphasis now in our funding, our bidding work, all around what is the route to adoption then? What are you going to do with it once you finish this project? How do you follow up with people? What's the follow on? Does this data set need building on and publishing? And I think Spring has a role here too as their centre of excellence. You know, how would we keep track of how well these projects have landed? What are people doing with it? Where do all these benefits coming from? There must be some ongoing case studies that maybe we could keep writing that shows from today in releasing this data set out to all, what have you done with it? What are the new service offers? Where are the improved models? And just generally, are our customers here in the UK and Ireland, are we getting the benefit that we predicted? Thank you.
Thanks, Kieran. And so another question from Anthony here was, which I think you've already answered in regards to the XML, but he's asked, will the dataset include pipe asset details alongside the images?
Yeah, so it includes the pipe diameter, the pipe material, direction of travel. So yeah, so the captured information from the CCTV report is withheld in that image. So it does give that the benefit of that data set. Yeah.
Fantastic, thank you. There's a question here from Ashwini that says, when we talk about infiltration, just wetting of surface and not flow of drops, how does AI answer this? As water, which is used while cleaning, trapped in the cracks or infiltration? Yeah, classic problem for any CCTV survey, and part of the reason why we want to do and utilise AI software, etc., are the age-old questions of, is that a defect? Is it not a defect? I do a lot of training, so globally on this subject. 20 people in the room, we all have a disagreement about how to code or classify. So things like infiltration, obviously quite difficult to observe and to accurately assess, but that's really where the experience of, and why we see a definite role for the human. However advanced the AI takes you, there'll always be a role for a human to interpret what they're seeing and what the reports are telling you, pretty much as they are now. But I think the AI will obviously do a lot of the more mundane, but there will always be a role for a senior engineer or an experienced engineer to look at it and to assess it and accurately code it. We don't want to hand over the controls to the AI just yet.
I think it's possibly worth just adding to that one. I think one of the project partners, the data set we were sent images because they had already been spliced, and they'd actually been through an AI model with the different defects assigned, but there was still they were chucked into the bucket with everything else, and we looked at those, but there was a lot of change and updates that needed to be made from those as well. So, and that's really the point of this output, is it's a training data set. It's providing more and more of these images so that an AI model can be able to recognize it with more accuracy and more certainty. So it's only through using things like these AI models, will some of the nuances and disagreements between kind of in people's different points of views of what people are, that's going to reduce, and the accuracy can only be achieved through having the data sets to train the AI models with. Yeah,
and the good thing is with this data set, it is classified to the rules or to the specification set out in the UK, i.e. the MSCC. So rather than somebody else's interpretation, this is the sort of the, not the holders of the rules, but the people who lay them out in the manual. So it is a good data set in that. It's not somebody's interpretation from what they believe. This is trained people doing the interpretation, the classification. So yeah, it's not ideal, it's not perfect, it never will be, but it's a long way forward in progress. Yeah.
Amazing, thank you. I don't know if this kind of adds on to that previous question there, was just to say, how many examples do you consider enough for the AI to learn from?
1,000. That's the one thing I've learned. 1,000 is the key number. It's not realistic though in a lot of cases, because I mean, some companies you're talking about, a company may have 10 examples of a specific failure code. So now we've got 70 instead of 10 because there were 7 water companies contributing. So that's the method we're aiming towards. But data is better than no data. But 1,000 isn't always realistic. Yeah, we had initial conversations with many of the existing vendors, people who are doing this day in, day out, to populate a data set for their own models, and they provided really valuable information in terms of how much data do you need. So we settled on about the 1,000 mark. That was the sort of the feedback we got. However, they did say any data is better than none, because obviously you can't train anything without a clear image to set it out. And then, you know, we can go into the realms of neural logics, etc., creating false images and all that. We didn't go down that route as yet, but I think the aimed figure of 1,000 was a goal that we sought, and for many codes we were able to achieve that. However, for the other 72, we did provide some data which will enable the software to move forward. So yeah, we haven't gone all the way, but we've gone a sizable distance down that pipe. So there's a pun I didn't want to do.
Perfect, thank you. And just to kind of go, just to wrap us up, we've only got a couple of minutes left. So just on the last question, what are the next future developments of this project?
I think that there are a lot of different possibilities for this. I think that's what's quite exciting. Obviously, there's the updating and keeping it up to date. As more and more surveys are done, more data is produced, and that can be used to supplement what's already there. So I think that's a definite possibility. There was a lot of interest in having the short video clips instead of the still images, because obviously that's what an AI model will be used to, and it would probably be more accurate. So that's another future development possibility. There's also the options of, now that there's a one benchmark data set, could it be used to almost have a certain level of evaluation? Could you evaluate models and give them an accuracy score? So actually across the industry, and this was something that was raised early on in the project, in terms of, could there almost be a testing facility, and could you a company upload their results of they've downloaded the data, their model runs through each image and says what it is, and then you could upload it and you could have a percentage score. We chose not to do that because it was just out of the scope of the project, but also it gets into the questions of, you don't want to be biased towards certain images than others, and it becomes more of a challenge that way. But that's also another real possibility for the future.
Yeah, no, definitely. And I think we'd be really open to feedback. Yeah. That people using it can feedback to us and say, ideally, if this could happen, and that could lead into new collaborative projects where we could work together with the industry again. This is, and I think it goes back to Kieran's initial message, this is here to benefit the whole sector and to accelerate things. So if there are improvements that are fed back to us, we can then discuss that with the industry and can say, does it need project number 2 to take it in that direction? So I think the feedback is really key to making it work and to making it accelerate and benefit the whole sector, because the water industry and the wastewater sector has got plenty of challenges that we need to solve. So hopefully we can be a small part of that.
Amazing. Well, thank you guys. We are coming to the end of our showcase, but I just wanted to let everybody know that I have popped a poll in the chat there for you guys to answer if you wouldn't mind. Just a few questions about the showcase and how informative you found that. But I just wanted to take the time to thank the guys at UU and WRC for helping us put on this showcase, and also the project partners involved in the project as well. Just to let everybody know on the call that there will be the case study and data set is available on the Spring platform right now. So please head over and check that out. We'd love to hear your feedback on this as well. And also just to let you know that the recording of this showcase will be available alongside that case study shortly too. So for anyone that couldn't make the call today, you will be able to rewatch this at a later stage. So a big thank you to the team at WRC and UU, and thank you everybody for joining us today.